All right, hello everyone. So welcome to the third of a series of videos on using the direct comparison test to show that a series converges or diverges. So today we're working on C here, series 1 to infinity, 5 minus sine n plus negative 1 to the n, all of that over n to the fourth. So we're using the direct comparison test. An is greater than or equal to 0 is less than or equal to an less than or equal to bn, and if bn converges, then the series an converges, and if the series an diverges, then the series bn diverges. Okay, all right, so we have 5 minus sine n plus minus 1 to the n over n to the fourth. That's our sequence, and yeah, we'd like to work with an inequality here. Now, with this type of sequence, I notice a couple things that are, you have that sine and that minus 1 to the n. And what I'm noticing about that is that sine is bounded. It can't be, sine is greater than 1. Sorry, sine is less than 1, I'm sorry. And it's less than or equal to minus 1. And minus 1 to the n, it is squeezed in between 1 and negative 1. And what I can do with that is I can build up an inequality for the numerator. And I would say the following, that the biggest this numerator could be would be 7. Because sine of n, that could be, it goes between minus 1 and 1. Well, if sine was negative 1 at some point, then a negative there would make that into a plus 1. And the minus 1 to the n, that could be 1. So 7 would be the largest value for it over n to the fourth. And some people say, well, you know what? I see the inequality the other way too. Okay. And I would say that the smallest this could be on the numerator is 3. Okay, sine would be, if sine was 1, let's say, 5 minus 1 is 4, and then if minus 1 to the n was negative 1, 4 minus 1 would be 3. Okay, so that's how I'm thinking about this. So both of these inequalities are true; they work out. However, one of them is only going to be useful here for us in terms of using the result, and that's the one on the right hand side. Because if you go back and look at the test, the test says, the direct comparison test says that if the bigger one converges, the smaller one will as well. So that's what's going to happen here. 7, series 7 over into the fourth, or take the 7 out if you want here, it doesn't affect the convergence or divergence. That's a p series, and with p equals 4. Okay, so it's going to converge. Converges because p equals 4, and therefore by the, so my 3 dots mean therefore by the direct comparison test, the series 5 minus sine n plus minus 1 to the n over n to the fourth converges. Okay. Now, the other inequality wouldn't help me if I looked at the series, sorry, the other side of the inequality, 3 to the n to the fourth. That doesn't help me because that would converge as well. It's a p series with p equals 4 when you take the 3 out. But just because the smaller one converges doesn't say anything about the bigger one, okay? You can only use the test as exactly as stated, okay? And there we go. So that's how we can find another inequality. Yeah, and if you've seen my previous videos, that's all we've kind of done here. Now, one thing to mention here, I just want to real quick, a lot of people ask me, well, when would you use, you have two kind of comparison tests. You have the direct comparison test and the limit comparison test. And where would you use which one, in which cases? So for example, here, I wouldn't use a limit comparison test because of, you have the minus 1 to the end, the sine. You have a bunch of like terms there that maybe don't quite behave really well when you're taking limits, okay? That's the way I'm seeing it. I'm like, nah, no thanks. And there's a couple other ones here. So this one here as well, B, the series 2 to the n over 10 to the n plus cosine squared n. I don't know if I want to use a limit comparison test because I have the cosine and I have a exponential, the 2 to the n and the 10 to the n. So yeah, I don't think that limit would come out too nice. And finally for A, yeah, maybe there. If I were to do a limit comparison test with 1 over n, maybe that would work out. But in these instances for B and C, that's where for my opinion, that's where the direct comparison test really shines, because you've got complicated series for which you can work with somewhat easily with an inequality. Okay. All right. Well, I hope these videos helped out. Thank you for your time.